remember you will be getting the e-notes as well as the recording will be available in a couple of days, and then we will be able to discuss that. Ladies and gentlemen, we spoke a lot about vertical projectile. I'm not going to bother you with all this. And Ponso, I'm going to make it easy for you just to try and follow with the problem that we are going to do today and everything else. The rest will now sit into place because the choice of the question for today was basically based on actually assessing the basics as well as ensuring that we understand how best it is important for us to actually read and understand the question. Lesedi Katadi, this thing here says a stone is thrown vertically upward at a velocity of 10 meters per second from the tower of the height 50 meters. Above, after some time, the stone passes the edge of the tower and strikes the ground below the tower. Key critical information here. Mr. Ditabe, where do we start with trying to attempt such a problem?
Trajectory, sir.
Trajectory. Thank you very much. What is trajectory, ladies and gentlemen? Trajectory is just a basic, simple sketch that I am going to use to try and understand exactly what information do I have, where am I in the motion of the projectile. The reason for that, ladies and gentlemen, is I don't want to assume that I understand what the actual statement is saying. However, I am going to say I know that the stone is starting there at the edge of the cliff. It is going up, let's say Dikatadi, and then it comes back to the starting point. Allow me, ladies and gentlemen, to say, how about I say this point is A, B, and C. But now there's something else that is happening thereafter. What is that something else? That something else is I have this window here and there, which is just now about 1,5 meters. Ladies and gentlemen, allow me to say this is D and this is E. But what do I know about D and ECD? It means it will now pass DE and actually hit the ground at point F. Why am I doing this, ladies and gentlemen? Then I have a D there and then I have an E there. Why am I doing this, ladies and gentlemen? VC, very easy. For actual understanding of where am I in the motion of the projectile. Ladies and gentlemen, I can now basically write all the information that is given to me. First information, a stone is thrown vertically upward at 10 meters per second. So from A, VI is equals to 10. At B, what do we know, ladies and gentlemen? V is equals to 0 meters per second. Now, Ponso, at C, because C it's now based on symmetry with A, it means we will just say V is equals to 10 meters per second, just in an opposite direction. Why am I saying that, ladies and gentlemen? Very, very easy. Only because of symmetry. However, I am told that from the height, from the top of the tower to this, I actually have now 50. So what makes my height there is basically C, D, E, and F. So VC, I have actually analyzed everything here. Now I can actually attempt to try and do what? And answer the questions that follow. By doing this, I am checking the mark allocation here, ladies and gentlemen. And there's a skill question of about 7 marks. I want to get 7 out of 7. The question is, how best can I do that? 8.1, it says, draw a labeled free body diagram showing all the forces acting on the stone during its motion. Now, ladies and gentlemen, we are working with a projectile. Lesedi Katadi, definition of a projectile, please.
As a projectile is an object that has been given an initial velocity and on which the only force that acts on it is gravitational force.
The only force acting on it is the gravitational force. What does that mean, ladies and gentlemen? It means whether the projectile is going up or down. Let me use the tools that I have here. Whether the projectile is going up or down, the only force acting on it is a force of gravity. Then I will be in a position to say this, ladies and gentlemen, it is just FG. Then I will be given my 1 mark in that regard. Why now? Because as per the definition, it is an object that has been given the initial velocity, and the only force acting on it is a force of gravity. So this should be easy to understand because it is basically a definition, ladies and gentlemen. We cannot have 2 forces, 3 forces as if we are working with Newton's laws. We cannot, because the condition of an object to be a projectile, I said it before, it must only be experiencing the force of gravity. Let's go to 8.2. Calculate the time taken by the stone to reach the maximum height. VC, which one will be best in terms of the motion of the projectile? Which parts of the motion will assist in us actually getting this answer correct?
So you're asking which equations of motion we should use?
No, I'm asking which path in our trajectory will assist us to actually answer 821.
So is it the velocity?
Let's read the question. Besides the question says calculate the time taken by the stone to reach the maximum height. Now my question is, when I look at my trajectory, the sketch, which parts of the motion will assist me to answer this question? I'm not asking equations. I am not asking what is this formulas. I'm just asking which parts of the motion should we consider?
Is it B, sir?
A, B. Now I'm going to tell this examiner to say from A to B. Why from A to B, ladies and gentlemen? Because A to B actually includes the maximum height. Where is the maximum height? The maximum height is now at B. Now, they want time. That is what the examiner is looking for. What can I write down? My data. Do I have V initial? Yes, it is given 10 meters per second. Do I have V final? Yes, ladies and gentlemen, I wrote it there at B. V is equals to 0 meters per second. Why is it 0 meters per second? Because remember, it is going to change the direction, Ponzo. It was going up to reach the maximum height. Now it is coming down such that it can be able to reach the ground. So the object will not now change the direction without stopping. What else do we have, ladies and gentlemen? G is always given. It is 9.8 meters per second. Now, Mudiana, what else is missing? Or what is going to be our biggest mistake here? You can assist Your Excellency, Mr. Ditabe. What will be my common mistake here? I have everything, but there's one small thing that is missing here.
So you're missing the third. No, you already have three variables.
There's one thing that is missing that is going to make this thing completely wrong. No, Mudiana. Thank you very much, Excellency.
Oh, sorry, sir. But I'm not sure. I think that you have to put a negative in front of the 9,8 since the force is acting down.
Thank you very much, Nomo Diana. In simple English is I must choose the direction. And I'm going to write there, remember, ladies and gentlemen, choice of direction. Why choice of direction? I am working with vectors. You are correct, Neo, to say because now I am choosing upward is positive and force is downwards, then it must have a negative. So most of our learners, when we mark, they tend to make a mistake of not choosing the correct uh, choice of direction, ladies and gentlemen. And that is very, very critical. So if I did not do that, automatically my calculations are going to be incorrect. So I need to tell the examiner to say, I am taking upward as positive. But you know what we are going to do now for these papers that are coming? We are actually going to tell you to take downward as positive and see if you actually understand. Because if you give you a freedom of choice in terms of the choice of direction, ladies and gentlemen, believe you me, the memorandum gets very, very big. So we want to minimize that by doing what? By telling you to say, take now what? Downward as positive and see if you actually understand the meaning of downward as positive and upward as positive. So ladies and gentlemen, in this instance it says everything going up should be positive. Now I just go to my formula sheet. Remember, don't memorize, the formula sheet will be there. Vf is equals to Vi plus Gt. Then it becomes easy to say this is 0, this is 10 plus minus 9.8 t, and then when I do the mathematics I find t is equals to 0.2 seconds. Ladies and gentlemen, what made it easy? VC to know where I am in the position of the vertical projectile motion. Yes, VC.
So I wanted to ask about the G. Does it matter if I say G or A?
The formula sheet usually has an A, if I remember well. Is it A or G? I think it's twofold. It's A and G. Now, you use A for only horizontal motion, and we use G for vertical motion. In grade 10, if you remember, the car was moving horizontal on the ground and we will use A. In this instance, the object is moving up and down, so it is G representing the gravitational acceleration. I am not sure if you are following, VC.
Yes, I understand. Thank you, sir.
Thank you. But generally the equations is the same thing, but when you get the formula sheet, just check, are you working with Newton's laws? Yes, horizontal motion. Then it means if you are going to use an equation of motion, then it must be with A. When you get to a question with projectile motion, the equation must be a g. Why, ladies and gentlemen? The motion thereof, it is under the influence of gravitational force and gravitational acceleration. Now, Lesedi Katadi and Your Excellency Mr. Tumelo Ditavi, one of you should tell me, ladies and gentlemen, at 8.2, calculate the maximum height that the stone reaches above the ground. Which part of the motion should I consider? That is all I'm asking. One of you can just open the yes.
It's AB, sir.
It's AB, ne? Why AB, ladies and gentlemen? AB only because, ladies and gentlemen, I am going to say at 822 the motion from A to B. Why? It is going to assist me to actually get now my height there above the building, which will be delta y. So what am I going to do, ladies and gentlemen? Very easy. The data is still the same. Why is it still the same? Because it's the data moves from A to B. So I'm just going to choose the equation to say Vf squared is equals to Vs squared plus 2g delta y. Delta y. V final 0 squared. V initial 10 squared. 2 minus 9.8 delta y ratanang phehlo. Then when I do the mathematics, delta y is equals to 5,1 meters. 5,1 meters. Does it answer the question now, Mudian? Maximum height that the stone reaches above the ground. This is actually above the tower. Does it meet does it answer the question though?
No, sir.
No, it doesn't. So what should we do now?
So you have to add the 5,1 to the 50 meters
Thank
of
you
the
very much.
tower.
Thank you very much. Why, ladies and gentlemen? B, C, D, E, F is what is above the ground. So it means AB 5.1, BC 5.1. Now B, C, D, E, F is actually what is above the ground. So I already have an indication, ladies and gentlemen, to say now the height there must be equals to 50 plus 5,1, which will give me 50,55,1 meters. Then I have actually got my question right and with proper understanding, ladies and gentlemen. So I am not trying to do anything complex. The only thing that I am doing is what? Is me trying to, it's me just trying to follow my trajectory, because the trajectory, ladies and gentlemen, makes my work very easy. It makes my work to be clear in terms of where I am in the project. Ladies and gentlemen, allow me now to remove everything here. Remember, you'll get the e-notes, not a problem at all. But I want us now to go to 8.3. Using a reference or using the ground as a reference, sketch the position time. Position time position versus time. Position versus time. Maybe let me ask Ratanang Pesho. Maybe let me ask, what does it mean when they say using ground as a reference, as a zero position? Just in simple terms. What do they mean using the ground as a reference?
So isn't it when you start drawing from the ground, or I'm not sure. So.
Okay. Maybe I should ask you Ponzo also. I understand it's a new topic to you, but this is just basic English. What do they mean when they say using ground as a reference? Just in simple terms of English.
Sarah, I'm not sure, but isn't it working from the ground, starting from F?
Starting from F. Okay, thank you very much. Ladies and gentlemen, what it means is, let me write it down so that you don't forget. It means this is the end point. It must end on the ground. I agree. But it must be now the end point of the trajectory. Now, it means also the object must be 50 meters above, must be the total height, above the ground. Ne? So now what does that mean? It means it will start there. This from here to, let me use a different pen. This part, sorry, this part here, it is the 50. But what does it mean? It says the object must be the total height above the ground. So it means somewhere up here, we are going to have our 5.1. So it must travel from 50 to 5.1, come back and just hit the ground. Then when we want to label it, we can easily tell that it took something like 1,02 seconds to do what? To reach the maximum height. And then this, there, ladies and gentlemen, it will be time in seconds, but in actual fact, it also represents the ground. So this is the tower. This is above the tower. And then it will look something like this. Ladies and gentlemen, allow me to write here to say ground as reference. I'm going to change it for the purpose of closing all the gaps. The examiner now says roof of the tower, roof of the tower as reference, or top of the building as reference. How will it look like? Let's draw. Because this is where now we lose a lot of marks, ladies and gentlemen. And we are only losing a lot of marks because we basically don't understand the meaning of ground as reference, roof of the tower, or top of the building as reference. Ladies and gentlemen, it will be something like this. It will be something like this. Now, this here, ladies and gentlemen, it's now the building. Let's write time first. Time in seconds. But that's this line now. It does not represent the ground anymore. But it actually represents, let me write for this case, roof of the tower. Some questions will come up saying top of the building, anything you'll understand as long as it is not ground as reference. What does that mean? It means this part here must represent A to B. So it will go up, come down to the top of the building. So A, B, C. But what will it do now? It will move down and actually cover now what? D, E, as well as F. And then there we say this is actually now the ground. Now, ladies and gentlemen, can you actually see the difference between the two? The difference is the examiner is saying in this one, ground as reference, but in this one, roof of the building or tower in this instance as reference, ladies and gentlemen. So this is very, very important, and it needs to understand exactly where are you in the position of a projectile. Your Excellency, questions please.
I'm good.
Thank you very much. Now, Mudiana.
So I'd just like to ask, so when they ask for the reference, it's basically where the zero will be.
Where the zero will be. Thank you very much. Nice and simple terms for each and every one of us to actually understand.
Thank you, sir.
Thank you very much. Because, ladies and gentlemen, you are going to draw any graph that you want. But if they don't tell you which one to draw, but for position versus time, we usually do. We will tell you we want you to draw this one or that one, depending on the examiners thereof. However, we are going to definitely be asking you to be drawing either ground as reference or top of the building as reference. So that is very, very critical, ladies and gentlemen. Very, very, very critical. You can easily lose that 3 marks just by not knowing how the shape of the graph should be like. So it becomes a very, very serious problem. Ladies and gentlemen, let me give you your 50 seconds to actually digest everything. We have covered a lot of ground. We need now to take a breather, drink water, and just unwind and keep your mind focused. So your 50 seconds starts now. Ladies and gentlemen, thank you very much. Let's actually now look into it. At 8.4 now, VC at 8.4. On its way down, the stone takes 0.1 second to pass the window of the length 1.5. So this examiner is telling me now something about t there, which is 0.1 seconds. Do you see now the importance of having the sketch? T there is equals to 0.1 second, as shown in the diagram above. Calculate distance yi, and yi is actually DEF. DEF. I want us to agree. This year it is DEF. So whatever I do, ladies and gentlemen, for me not to be confused, I am going to write here, sorry, to say, can I look into the motion of DE first? After looking at the motion of DE, I can look into the motion of EF. Why, ladies and gentlemen? I said to you to make your life easy. This subject is very dynamic, but you always need 2 points for you to perform a calculation. Did I say so, Lesedi?
Yes, sir.
Thank you, Mr. Ditabe. Inputs, please.
So, going back to the position time graph, you say where the zero will be, like what zero you're referring to? That's where I got low.
We are referring to the endpoint, where the object will actually stop.
At the x-axis.
Let's say yes. Let's check this one of roof of the building. What Neo is saying, where the zero will be, it's because in this instance, the roof will be where the zero is. Hence, it is starting from A, B, C, and then it's going down under, because of the roof of the tower is actually our zero reference point or zero position. However, for the ground as reference, we basically mean where it is going to stop, above. Hence, I wrote it here. Endpoint, the object must be the total height above the ground. So it means our ground as reference, it must show the total height above the ground. But for roof as the top of the build, roof as the reference, it will show two parts of the motion. The first part, ABC, top of the building, CDEF, under the building, or as it is approaching. So it basically just says for roof of the building as reference, 0 point. But now ground as reference, the total height above the ground should be indicated. Yes, Your Excellency, Mr. Ditabe.
Okay, sir, I get it now. Thank you, sir.
Thank you very much, big brother. Ladies and gentlemen, let's move. As I was saying now, we agreed, ladies and gentlemen, to say for me to perform a calculation, I need 2 points. One can say that number, and I want to use A, B, C, D, F. It's fine. You can do it in so many ways. But remember, you will need to calculate A, B, B, C, C, D, E, F, D, E, and then you combine everything because you actually need 2 points. You can take whichever one. In this instance, I have D, E, F from my diagram. So I'm going to make my life very easy, ladies and gentlemen. Very easy. And say I am working from D, E. And what am I going to do with DE? I'm going to write the data given. T is equals to 0.1 second. Delta Y, is it given? Yes. 1.5 meters. Bonolo, do we have any other information that is given? Because remember, I need how many variables to perform a calculation? Yes, Bonolo?
Sir, isn't it at least 4?
I need 3, and the third one is a constant, which is G 9.8 meters per second. Remember, we always need only 3 to perform a calculation. The fourth one will be the question. The question in this instance is what? Let's ask ourselves. If I can get the velocity at which this object is traveling to D, will I be assisted for me to use now the information of BC and then just subtract that? Let's try and do that and check. If I know from I'm at D, ne? I want V initial at D. Let's check if it's going to assist. Then I'm just going to say delta Y is equals to VIT plus half GT squared. 1.5, everything must be negative. It is going down, negative. V initial is what we are looking for, times 0.1 plus half of minus 9.8. It is going down, 0.1 squared. V initial, it is going down, it is minus 14.51 meters per second. V initial basically means 14.51 meters per second, comma, downwards. Remember, never leave your answer as negative. So I'm going to write it here at D to say I have D now as 14.51. And then I'm just going to say, fine, ladies and gentlemen. If I have what is this? If I have V initial at D, which is 14.51, can I be in a position of finding this height from the maximum height, BC or BD? Let's work with BD and check. From BD, from BD, what is happening at BD? V initial is equals to 0, Y maximum height. V final is equals to 14,51 meters per second. G is a constant 9.8 meters per second squared. What can I calculate? I can get delta Y there. So V final squared is equals to V initial squared plus, ladies and gentlemen, 2G delta Y minus, because it was going down, 1451 squared, this one 0 squared, plus 2 multiplied by 9.8 minus, it was going down, and then delta Y here, ladies and gentlemen, it's something like 10,74 meters. Now let's check, ladies and gentlemen. BD, it's 10,47, which is BD there. So if I can say, I know that the height or the total height here is actually 55.1. Bonolo, is it correct from the previous slide?
Yes, sir.
Then we just minus this 10,74, and then it will give us something like 44,36 meters. And this will be the height there of now what? Y1, something like that. Or YI, sorry. But there it says Y1, here it says YI. So yeah. VC, questions please.
Nothing from my side, sir.
Very clear, ne?
Yes, sir.
So what is your take? What makes this problem to be easy for you to actually comprehend and understand?
So, the sketch and then separating by saying from D to E and then from B to D, it
You
breaks it down.
ne, because you also don't eat a whole loaf of bread at once. What do? You break it down into smaller slices. 1, 2, and then you come back again and eat 2. So because of us breaking it down, it makes it easy for us Ratanang Phehlo, Pontsho Mohailane, Tumelo Ditabe to actually understand where are we in the motion of the projectile. Ratanang Phehlo, inputs please.
So I don't have any questions, sir.
Do you follow, or what makes it now more understandable for you?
So I understand when you use the different points to get the displacement and then we minus it, sir.
And the data thereof, because now knowing exactly which data you are going to use, that data assists you to actually know and choose the correct formulas. We usually say we want 1 mark for the formula, but it's going to be incorrect formula if you have incorrect data. So to eliminate that already, what are we doing? Very easy. Let's start by ensuring that we have the correct points to actually use. Somebody asked me, and that Nambane, is it allowed to draw this sketch in the exam? 100%, ladies and gentlemen. Why? Because the exam, the marker, remember the marker is also a physical science teacher. Some of them are specialists. When you say from BD, they will actually look into your diagram, try to follow what you are attempting to do. Even if you might not get 7 out of 7, but the fact that your point of reference is known, you might just get 6 out of 6 because of a smaller mistake somewhere there. Hence, my intention with you is I don't want to teach you the correct answers. I want to teach you the correct approach, because all these questions will change, will change, will change. But where are you in the motion of the projectile? Ladies and gentlemen, we have exhausted the approach. Allow me now to introduce what we call a bouncing ball. Ponso, are you still following? Am I too fast or too slow?
I'm okay, sir. I'm following.
Thank you very much. Kindly tell me if I am too slow. Some people say I'm very, very slow. And then I said to them, you must listen to my voice at 1.5x. Then maybe it will be better. Ladies and gentlemen, what does this thing mean? This thing means an object at a certain height, it will go to the ground. It is thrown vertically up, comes down, past the point, and hit the ground. But because it's a tennis ball, somehow it decides now to go up and bounce off the ground. So this now, it is a bounce. My question has always been, how do we treat this thing of a bouncing ball? How do we make it more entertaining and more nicer? And then I said, there's no other way, because this thing actually combines two principles in it. Allow me to write my ABCD, because it makes my work easy. A, B, C, D at bouncing, and then E there. What is happening, ladies and gentlemen? Very easy. Our notes told us that at A, V initial is greater than 0. At B, V is equals to 0. At C, Vi is equals to V at C at A there. What do we know? At D, V final is greater than, let's not say final, let's just say V, greater than 0. And what will happen now at E, Bonolo Matosa? What will be the value of V?
0, sir.
0, lady. Y, maximum height. So can you see, it is basically just a repetition of first part of the motion and the second part of the motion. The only thing that is new, it's at D, it's just bouncy. Neo Mudiana, at D, is it a collision?
I think so, sir, that it's a collision with the ground. Then it
No.
will be after.
And which law is applicable for us to work with collisions? Or maybe let me say, how many objects do we have in this instance? Is it 1, 2, 3? How many objects do we have?
One, sir.
1. Now, if it's 1, which principle allows us to work with collision of one object? You can help Lesedi Katadi. You can help anyone. You can assist. Which principle assist us to work with a collision of a one object of or of a single object?
Sir, is it impulse?
100%. It is impulse because impulse says I need to have one object that is in a collision. And that one object that is in a collision
Yeah, it's impulse.
is impulse, ne? So can you see now how these two topics are coming closer to one another? Because if Neo is saying a D is a collision with the ground, if it's a collision, it means we are going back to the momentum. And then here, ladies and gentlemen, I must apply F net multiply by changing T is equals to changing P, which is the impulse. Why? I am going to have V at D, V at E, and also the force at which it is taken to apply there on the ground. I can also maybe ask what is the T there after it has hit the ground. Can you see, Ratanang Pehlo, that now the concepts of momentum are now actually coming into existence when we work with a bouncing ball? Why, ladies and gentlemen? I gave you the best hint ever. And I don't know if it is assisting or not assisting. Is it assisting, Mr. Ditabe, to say if you have one object, that object must be, or the principle that is 100% applicable will be impulse. If you have two objects, the chances are you are going to use conservation of linear momentum. Did it assist, Mr. Ditabe, when you were doing your momentum after the discussions here?
Yes, it did.
Katanang Pesho, did it assist?
Yes, sir.
Thank you very much. So, ladies and gentlemen, it's working. So we are going to ask you things of momentum, especially when it is a bouncing ball. So it is not anything funny or anything new. It is just that we are extending it to say, fine, what happens when it now bounces off the ground? Ladies and gentlemen, it depends on the nature and the type of the ball. You can have a soft tennis ball, or you can have a hard cricket ball or a golf ball or something like that. Something that is very, very hard. When you draw the trajectory, this is just the trajectory, because in this instance, both of them are dropped. And when both of them are dropped, maybe what must I do? Let me do this. I want to take this thing and just put it aside. And just to show you, I will bring it back to say when it is dropped, it is type 1. Dropped to the ground. Sorry. It is now dropped. What does it mean when it is dropped? V initial is equals to 0. But obviously it is coming down. Hits the ground. I am going to do what I normally do best. What is that? A, B. At B, I know V is greater than 0. because it is hitting the ground with a certain velocity. It then bounces off, ladies and gentlemen, to C. And at C, Neo just told us to say at C, V is equals to 0. Why, ladies and gentlemen? Comma, maximum height. Now allow me to take this, put it somewhere here and make it smaller and come back here. I want to show you the similarities between these two. Because when I look at it, honestly, it's just the projectile combined with impulse. And the part of impulse that we are interested in is just the okay, don't know what is happening here. Maybe let me somewhat delete. And redraw quickly. Now we decide to throw it vertically up, goes up, comes to the starting position, hits the ground, and then bounces off. Okay, somebody say, but we want it to bounce a couple of times. Fine. Let it now come down again, bounce, and then bounce off. Now I am going to do what I do best for the purpose of me understanding. A, B, C, D, E, F, G. Now, with that said, I can write and do everything that I know. We agreed V initial greater than 0. V initial equals to 0. V initial equals to V at A here. V greater than 0. V is equals to 0. V greater than 0. V equals to 0. And the fact that I have A, B, C, D, V, C, it's easy for me to say where am I in the position of the trajectory of the projectile. I am in DE. Then I can work with DE with high level of confidence, because the examiner is going to ask me how up, how high below the building is the ball after the first bounce or something like that. So I will know where am I in the position of the project. Then it makes it very easy, ladies and gentlemen, to actually understand. So there's nothing complex. The only thing that you must just remember here is that we have a bounce here, and this bounce, we relate it now to F net multiply by changing T, which is equals to changing P. Why, ladies and gentlemen? Because that is the only concept that allows us, when we have one object that is now colliding with itself or the ground, sorry for that, then it means we can only do that because we know M V final minus V initial, ladies and hence the M is only for one object. However, we have two different types of balls: a hard ball and a soft ball. So when we have a hard ball, ladies and gentlemen, what does it mean? It means here it changes shape because it is elastic. It is an elastic ball, so it is changing shape. So hence it is taking now these positions here for it to actually do what? For it to actually last longer in the uh, when it is actually colliding with the it's taking some time there. Why, ladies and gentlemen? Because it is changing shape, it is expanding for it now to be able to change the shape. However, the hard ball does not change the shape, hence the contact time here is very small because it hits and just drops. It does not even bounce off at times. So the difference between the two is when you check the graphs that will be given. It is important, ladies and gentlemen, for you to realize that this one is now taking longer contact time. Let me write it with blue. Longer contact time. This one shorter contact time, because these questions we do ask in the multiple choice. These questions we do ask in a terms of you expected to draw a position versus time graph. So this one, ladies and gentlemen, does not change shape. Why? It is rigid. Because of that, now it is not changing its shape. That is the reason why the contact time is very short. The velocity versus time, because we are talking of the dropped ball, ladies and gentlemen, allow me to make a smaller and a sketch there. We will always have, when we take downward as positive, we will have something like that. It is as simple as that, because we agreed that it is starting at 0 and then it will hit now the ground with a certain velocity. It is exactly that. Hence, ladies and gentlemen, I can easily say VCA B, and this part here will also be B. Why? Because this part here, ladies and gentlemen, represents now the collision. Some people will also say it represents the bounce, but there it is now the contact time. But what is the difference between the two? Remember, this one is a hard ball, the other one is a soft ball. So the fact that now we are working with two different balls, we need to differentiate in terms of now what? In terms of the contact time between the wall and the object itself. That is the reason why, ladies and gentlemen, I can easily still say A, B. This is still B because it's going to change the direction. This will also be the collision, and this will also be the bounce, and C, that is when now it is hitting again the maximum height. Hence the velocity is 0. So the interpretation thereof, it is clear and straightforward without any other influence whatsoever. So ladies and gentlemen, this brings us to the end of today's session, and the time is 19:15 exactly, as I promised to say. I'm not going to take you more than 1915. So basically, ladies and gentlemen, we have incorporated everything that has to do with vertical projectile motion. Moteo CDT sometime back asked me, say, when are we going to do two balls? And I said, why do you want us to do two balls? Because two balls is basically two objects. So if you are confident with one object, then two balls becomes easy because there's never a point where two balls will be moving together in this instance. So we'll be treating ball A with its own independent information, treat ball B with its own independent information. However, there has to be something common. Hence, they are introducing the second ball. So tomorrow, ladies and gentlemen, we will do a smaller nyana section on a question on bouncing ball such that we can close it off, and then I will also introduce the two balls such that you can be able and have an idea fully on how to go about working with the two balls. Then I will confidently say with projectile we have exhausted it. But remember, with grade 12 you don't finish revising. The only thing that you can do is just know the concept and practice and practice and practice. Moteo CDT, reflections please.
So this lesson was good. I enjoyed it.
Thank you very much. Bonolo.
So this lesson was good as Mateo said. I think I have a better understanding, and I think also Noah made it easier when she gave her simplified reference definition sort of thing.
Thank you. Because remember, ladies and gentlemen, together we can do more. Sharing the light will not make your light dimmer, but it will actually assist you to have the light to be able to walk. Ratanang Phehlo.
So far, understood the stuff you said, sir, and this was a very good lesson.
It's detailed, ne?
Yes, sir.
100%. No, Mudian.